Hi everyone. In this video, I'd like to look at an application, a word problem. And in this word problem, I've given you two linear functions, and I really want to focus on the slopes of each of those functions and then the slope of the composition of those functions. So this is a big interpreting slope review with a little mini piece of composition review as well. Okay, so we have our two functions. The thickness of the ozone layer decreases by X%. Oh, if the thickness of the ozone layer decreases by X%, the percent increase in UV radiation is given by R of X equals 1.5X. Okay, so this X was decrease in, it's percent decrease even, in thickness of ozone layer. Okay, we're going to abbreviate a little bit. And R is the percent increase in radiation, UV radiation. Okay, so the first thing we're supposed to do, let me not get too far ahead of myself. Let me write down the other one as well. We also have a function C of R, which is equal to 3.5R. And here, R is again the percent increase in UV radiation, and C is the percent increase in number of cases of skin cancer. Okay, so those are my two functions. And the first thing we're supposed to do is identify the slope of R and explain its meaning. So identify, because you shouldn't have to do any work. You should just be able to look at R and say, this is a linear function. It's in y equals mx plus b form. B is 0, m is 1.5. So my slope is 1.5. And then if we think about this, function R, I draw this little picture for myself all the time when I'm doing slope. This is X's and this is R. So the slope is going to equal the change in R over the change in X. We can even make it a fraction to match up if we'd like to. So slope is always rise over run. So the top of the fraction is going to tell us how much R changes. The bottom will tell us how much X changes. Which means in this case, which one is X? The thickness of the ozone layer decreases by 1%, then there will be a 1.5% increase in UV radiation. And that one messes with people sometimes because it's a positive one, but X was defined to be decrease. X is the decrease. So if X equals 1, that's a 1% decrease. Okay, so again, if the thickness of the ozone layer decreases by 1%, there will be a 1.5% increase in UV radiation. The second part of this asks us to find the slope of C and explain its meaning. So C of R is equal to 3.5R. And once again, this is a linear function. The slope is 3.5 and the intercept is 0. So in this case, when we look at the slope, it's 3.5, and that's going to be R versus C. That's what we're looking at, inputting R's and outputting C. So change in C over change in R. These guys are deltas, if anybody hasn't seen those before, little triangles. We use those to represent change fairly regularly in math. Okay, so this time I would say if the amount of radiation increases by 1%, the number of cases of skin cancer will increase by 3.5%. So if there is a 1% increase in UV radiation, there will be a 3.5% increase in number of cases of skin cancer. Okay, and then last part here is where we get a little baby composition problem. So we're supposed to now find the composition C of R of X, which algebraically just means take R of X, which is 1.5X, and plug it into function C. Function C is really simple. It takes whatever we give it and it multiplies it by 3.5. So it looks like C of R of X is, let's see, 3 point, uh-oh, do I have a dead calculator? I might have a dead calculator. 3.5 times 1.5. Okay, let me think about it. Half of 3.5 is 1.75. So 3, 4, 5.25 x. Okay, so C of R of x is 5.25x. We are then supposed to identify the slope of this new function. So interestingly, when you compose two linear functions, what you get is a new linear function. We're supposed to identify the slope of this thing. So now our slope is 5.25, and then we're supposed to explain the meaning of that slope. So here, if we think about this new function C of R of X, and it's really important when you're composing to realize that's what you're doing. You're building a new function, and its name is C of R. This function inputs X's and outputs C's. Our final output will be a C value. So if we take that slope of 5.25, that would be a change in C over a change in X, which means that the slope is telling us that if the thickness of the ozone layer decreases by 1%, the number of cases of skin cancer is expected to increase by 5.25%. All right, thanks for watching.